Okay, so this uh, discussion will cover the quantitative part of the frequency distribution table, in which the focus will be mainly the steps on how are we going to construct the frequency distribution table. Now, if you will go back to the uh, concept of statistics, we have stated that statistics involves a process. Okay, so in terms of the statistical process, it covers first the collection of data, okay, followed by the tabulation and presentation of data, followed by the analysis of data and the interpretation of data. Now, in terms of the statistical process, your frequency distribution table, the FDT, is actually found on step number 2, which is the presentation of data. So from the previous discussion, we have um, covered the different ways on how are we going to present the data that you have gathered. Okay, so frequency distribution table is one of the methods on how are you going to present the data. So when we speak of a frequency distribution table, this is the tabular arrangement of the gathered data by categories plus their corresponding frequencies and class marks. Okay, so um, the frequencies, okay, class marks will be highlighted as we go through the steps. However, there's a notes which was given to you in terms of uh, covering the different definition of terms. Okay, so for this discussion, we'll just mainly focus on the computations part. Okay, so there's a separate handout that was given to you for us to cover the definition of terms and then the applications of those terms or examples of those terms. Okay, so when you speak of your frequency distribution table, for you to construct it, we will actually follow 5 simple steps. Okay, so for the presentation of data in terms of statistics, the first thing that you always need to do is for you to arrange your data, convert it from its raw form into an array form. Okay, so in which you need to arrange your data either from lowest to highest or highest to lowest. But for this discussion, we will be doing it from, or we'll be arranging our data from lowest to highest. Okay, so I do encourage you to follow that format as well for you to easily follow the steps that I'll be presenting in a little later. So again, the first thing that you need to do, the first step that you need to do uh, in any ways of presenting the data that you have gathered in statistics is by arranging the data. Okay, so the second step is for you to compute for the range. Okay, so how are we going to compute for the range? You just need to get the difference. Okay, the difference between the values of your, or between your highest and your lowest value. And the reason why we are going to arrange your data from lowest to highest is for you to easily identify what is your highest value, what is your lowest value among the given data, okay, among the set of data which was given to you. And um, the reason, or another reason why we are arranging your data from lowest to highest is for us also to have an accurate data in terms of our range. Okay, for us to have the accurate figure or number. Okay, so after identifying or after computing for the range, the next step is for you to determine your class intervals. So when we speak of class intervals, technically it will be dependent on the researcher. Okay, so class intervals will actually affect the number of groups or categories that you will be having in terms of your frequency distribution table. But the ideal number of class intervals is somewhere between 5 and 15. So you can actually have class intervals na 5 or even 15. Okay? Don't worry in terms of your activities. The class intervals will be given so that you'll be having the same solutions, you'll be having the same answers. Okay? So again, your class intervals will always be given. Next, after determining your class interval, next is for us to compute for our class size. For the class size, the things that you will be needing are technically your class interval from step 3 and your range from step number 2. Okay, so how are we going to compute for the class size? You will simply divide. Okay, you divide the range, the value that you have computed in step 2, you divide it by the identified class interval for you to get your class size. Okay, so later I'll be showing you an illustrative example for you to better understand what I'm sharing here. And then after determining or computing the class size, the class intervals, and even the range, you can now construct your frequency distribution table. Okay, so let's have an illustrative example for us to reinforce your learning experience. So we have here a set of data. So based from the example, these are actually the scores of the statistics class of Mr. Marcelo in their prelim exam. Okay, so uh, let's say Mr. Marcelo has 40 students, okay, in which these are their respective scores. Now, for us to again construct our frequency distribution table, the first thing that we need to do is for us to convert this raw data, okay, into uh, into its array form. Okay, so we need to arrange it first. So step 1, as stated from our previous slide, we need to arrange the data in its lowest to highest form. Okay, so this is our lowest number from the given. So there we have 9, followed by we have 17, okay, and then 18, we have 20, we have two 23s, 24, 25, 26, 27, up to 50. Okay, so the arrangement is from lowest to highest, and it's presented from top to bottom. Okay, top to bottom for each column. Okay, so that's our arrangement here. And after arranging your data from lowest to highest, the second step, based from our previous slide, is for us to compute for the range. Okay, so how are we going to compute for the range? You need to have your highest and lowest values. So we have it here. We have our highest value, our lowest value. Okay, so that's the reason why we have arranged our data from lowest to highest for us to easily identify those two values that we'll be using for us to compute the range. So in here, the formula for range, or that's the variable r, is the difference between highest value and lowest value as stated from the statement. So in here, we have the highest value, which is 50. We have the lowest value, which is 9. So the range is 41. Okay, so that's already the answer for step 2. Okay, so that's already the data for our range. So after computing for the range, we will now proceed to the third step, in which we will determine the desired class interval. So as I've stated a while back, class intervals will always be given. Okay, so for our class interval, let's say I will be using 7. Okay, so we'll be using 7. Now, the fourth step, the next step is for us to compute for our class size. Okay, so in terms of computing for our class size, as presented a while back, we'll be needing the data from steps 2 and 3, in which we'll be needing your range from the second step and then the class interval from the third step. Okay, so class size is represented by I. So if we will compute for our class size, we have 41, that's our range coming from step 2, and then we have class interval, the desired class interval, which is 7. Okay, so it's 7. So the answer is we have 5.857, but in terms of the class size, it's best for you to round it off to the nearest whole number. Okay, so if you have 5.85, if you will round it off to the nearest whole number, then we'll be having 6. So our class size is 6. So we now have our 3 data that we'll be needing. So you have your range, which is 41, class interval, which is 7, and your class size, which is 6. Okay? So next step is for us now to construct our frequency distribution table. Now, for our frequency distribution table, these are the essential elements. So first column is referred to as your lower boundary. Okay? So it's uh, identified as your LB. Okay, and then this is the column for your class interval, in which it's divided into 2 parts. You have your lower limit, upper limit, and then you have your upper boundary column, so identified as UB, and then we have class mark, so it's X, and then frequency, so we have variable F. You have your less than cumulative frequency, you have your less than sign, and then CF for cumulative frequency, and we have relative frequency. Okay, so we will be constructing the frequency distribution table, in which we will fill in all of this, or we will try to fill out all of this uh, needed data, okay, per column. So based from our previous slides, we have identified the following given. So we have first your range, which is 41. We have class interval of 7. Okay, so that's given. And then we have your class size, which is 6. We have your lowest value of 9, highest value of 50. Okay, so here are the important things that you need to remember. When we speak of your class interval, diba, this is given. This is identified by the researcher. Okay, your desired class interval. Your class interval here will actually determine the number of rows that you will be having. Okay, so it states here that desired class interval is 7, so meaning we'll be having 7 rows. So 1, 2, 3, 4, 5, 6, 7. Or to simply put, you may term that as the groups. So you will be having 7 class intervals or 7 groups. Okay, based from our data. So if this is 6, then we'll be having 6 groups. If this is 5, then we'll be having 5 groups or 5 rows. Okay. Now, as I've stated a while back, class interval actually refers to the grouping, in which from the data you will group them according to the limits, okay, according to the range per group. So for example, from lower limit of x up to upper limit of y. Okay, so any number that would fall within the range of this particular group, then it will be part of that group. So later, upon computing for the figures, I will further enlighten you of what I'm trying to share. Okay, so going back, the first thing that we need to do in terms of constructing our frequency distribution table is for us to compute for our lower limits first. Okay, the lower limit. And in terms of the lower limit, we will start from the bottom cell. Okay, so in terms of computing, or in terms of um, identifying the numbers for our table, we will always start from the bottom, okay, per column. So for the lower limit, we will start with your lowest value. Okay, so the lowest value from the given set of data will be the number that you'll be placing at the bottom, okay, of your lower limit column. So with that, we'll be having 9. Okay, so we have 9 here. And then for us to identify the succeeding numbers on your lower limit column, we will now use our computed class size. Okay, we will use our class size, in which from the first data, okay, for us to get the next data, we will simply add our class size. Okay, so as an example, we have it here. So 9, for us to get the next data, we will add 6. Okay, so 9 plus 6 will be having 15. Okay, so here we'll be having 15. And then for the next lower limit, okay, again we will be adding our class size. So 15 plus 6 equals 21. And then 21 plus 6 equals 27, in which your class size here will be the intervals of your lower limits. Okay, that's why it's very important for us to compute for our class size. Okay, so again, uh, for this column, you will start with the lowest value from your data set. So lowest value, you place it at the bottom cell, and then for you to get the next cell, the succeeding cell, you just add your class size. So 9 plus 6 equals 15. 15 plus 6 equals 21. 21 plus 6 is equals 27, and so forth. Okay? And next step is for us now to determine our upper limit. Okay? So for us to determine or for us to complete the column of upper limit, again, we will start from the bottom. Okay? So the simplest way for you to get your upper limit is by looking at your lower limit. Okay? In which for you to get your upper limit in this cell, okay, you look at the lower limit found on the next cell, in which you can simply subtract. Okay, subtract 1. Or for an easier computation, okay, for you not to be confused, here's another way for you to compute for the upper limit. So you have your lowest value. Okay, so let's go back from the previous slide. So you have your lowest value. For you to get your upper limit in this cell, you have your lower limit, you add your class size. Okay, so that's 15. You subtract 1. Okay, so 9 plus 6 minus 1 is equals to 14. So there. Okay, and then for this upper limit, so you again do the same process. So 15, which is your lower limit, you add the class size, and then subtract 1. So 15 plus 6, okay, minus 1 is 20. Okay, followed by, so for this one, we have 21, okay, plus 6, that's 27, minus 1, you will be getting 26. And then same here. So how have we identified 32? So we have 27 plus 6, that's 33, minus 1, it's 32. Okay, so there. So your class intervals here already represents the different groups. Okay, in which it means that uh, from numbers 9 to 14 or scores 9 to 14, okay, they will be found in this particular group. For those students who have earned a score of 15 to 20, they are found in this group. And then for 21 to 60 na scores, they are found in this group, and so forth. That's actually the purpose of your class interval. That's the groupings. Okay? So another way for you to check, okay, your class interval, or to compute for your class interval, is by looking at your lower limits. Diba? This is the first column that you have computed. Okay? In which uh, your lower limit here, if you will subtract 1, you will be getting your upper limit from the previous row. So if you will start from bottom going towards the top. Okay? So 15 minus 1, you'll be having 14. So 21 minus 1, you'll be having 20. 27 minus 1, so we have 26. 33 minus 1, that's 32. 39 minus 1, 38. 45 minus 1, 44. Okay? And the next step for you to get your upper limit is for you to simply add your class size, which is 6. Okay? So that's for your upper limit. Next is for us to, here's another way pa pala. So for us to identify the first um, value here for your upper limit, diba, we can use your lower limit plus class size, okay, minus 1. So 9 plus 6 minus 1 equals to 14. Okay, now the simplest way again for us to determine the succeeding numbers is for us to use the class size. So in which you can just add. So 14 plus 6, you will get the value here. And then, so here, 14 plus 6 equals 20. 20 plus 6 equals 26. 26 plus 6 equals 32. 32 plus 6, that's 38. Okay, so as I've stated a while back, the intervals, okay, between, or the difference between two succeeding lower limits or upper limits will always be equal to your class size. That will be the intervals. Okay? So next, let's move on to your lower boundary. For your lower boundaries, this is your formula. You have lower limit less 0.5. Okay? So we'll be doing it on a per row basis. So with that, if you will apply, we'll be having the following figures. So 9 minus 0.5 is 8.5. Okay, this is your lower limit minus 0.5. So 15 minus 0.5, that's 14.5. 21 minus 0.5, that's 20.5. 27 minus 0.5, that's 26.5 up to 44.5. Okay, so another way for you to appreciate the class size. Okay, so after computing for the first lower boundary, so 9 minus 0.5, that's 8.5, correct? Okay, for you to identify the next or the succeeding lower boundaries, you again use your class size. So based from our example, our class size is 6. So we have stated that the intervals for your lower limit, upper limit, and even for your boundaries will be the class size. Okay, so in which you have here 8.5. If you will add your class size, which is 6, you'll be having 14.5. You add 6 again, you'll be having 20.5. And then plus 6, 26.5. so forth. Okay, or if you want to simplify yourselves, or if you want to simplify your lives rather, you can just follow this formula. You have lower limit, you subtract zero point 0.5, you will get its lower boundary. Lower limit minus zero point 0.5, lower boundary. Okay? Next is for us to compute for the upper boundary. For the upper boundary, instead of subtracting zero point 0.5, we will now add zero point 0.5 to our upper limit. Okay, so this will be our base figures. Okay, so you have upper limit, so 14 plus zero point 0.5, you will be having 14.5. So upper limit plus zero point 0.5 will be having 20.5. So if we will fill in the data, we'll be having the following. So 14 plus zero point 0.5, that's 14.5. So again, this is your upper limit column. That's your given here. You add 0.5 for you to get their corresponding or their respective upper boundaries. Okay? So next is for us to compute now for our class mark. For class mark, we have this formula. Okay? So class mark is the same as your midpoint. Okay? In which, for us to get or compute for our class mark or our midpoint, we'll follow this formula. So you have the upper limit, so we'll be doing it per row. Okay? Upper limit plus lower limit divided by 2. So again, we will start from the bottom. So this is your lower limit, this is your upper limit column. So it states here that for us to compute for the class mark of the first row from the bottom, okay, then we need to get the summation of your upper limit and your lower limit, and then you divide it by 2. Or to simply put, it's actually the average of your lower limits and your upper limit. Okay? So we have 9 plus 14. So I think I have it here. Okay? 9 plus 14 divided by 2, that's 11.5. Okay? So we have upper limit 14, lower limit 9. You add divided by 2, that's 11.5. Okay? And then followed by 15 plus 20 divided by 2, that's 17.5. 21 plus 26 divided by 2, that's 23.5. Or again, as I have highlighted a while back, the intervals or the difference for two consecutive data which are found on your lower limit, upper limit, or your boundaries will always be equal to your class size. Okay, so in short, let's go back here. So let's say after identifying the first class mark, for you to get the next class mark, you just add the class size. Okay, so we have it here, 11.5. The class size based from our discussion is 6. Di ba? We have computed for 6 as our class size. So you add 11.5 plus 6. This is 17.5. Okay, so there, 17.5. You add 6 again, that's 23.5. Okay, you add 6, that's 29.5. You add 6, 35.5, up to 47.5. Or if you don't want to use your class size, you can use this formula. It's the same. Okay, but I'm just simplifying your lives in terms of computing by identifying the or by utilizing your class size. Okay, so there. Next is now for us to identify our frequency. Your frequency here refers to the number of data that would fall within a specified range. Okay? Or to simply put, diba, based from our example, these numbers actually represent scores. Okay? Scores in the prelim exam. Now, we have stated here that for individuals who have earned a score of 9 up to 14, they belong to this group. Okay, in which from the data set we will count how many individuals have gotten a score of 9 to 14, and then we will count them. We will place them as the frequency. Okay, that's simply what it means. And that's the reason why I have stated a while back that your class interval represents groups. Okay, so in here, let's look at the range 9 to 14. So from 9 to 14, we have, okay, how many numbers would fall within that range? From 9, the lowest, 14, the highest. Okay, so among our data set, or among the given data, how many numbers would fall within that particular range? So we have 9. Okay, 17 is already beyond 14. Okay, so meaning we only have 1. Okay, so if we only have 1, then we will place frequency which is 1. Okay, so followed by the next range. So from 15 to 20. Okay, so how many uh, data or how many scores would fall within this range? So from 15 up to 20. So let's go back again to our data. So we are looking for numbers that would fall within the range of 15 to 20, correct? So we have 17, it's within the range. 18, that's within the range. 20, that's still uh, part of the range. Okay, that's our maximum value for that particular group. So in here, we have how many numbers, how many scores? We have 1, 2, 3. We actually have 3 individuals who have earned a score, okay, within 15 to 20. So there, we have, or we will place 3 here, followed by, so for the next one, so again, the range 21 to 26. Okay, so scores that would fall within the range of 21 to 26. So again, let's go back to the data. Okay, um, we will now count again. So 23 is within 21 to 26. So we have 23, 24, 25 up to 26. So how many scores do we have? We have 1, 2, 3, 4, 5. So you write 5. Okay? Followed by, so we have the range 27 to 32. So how many scores would fall under that range? So we have 27, it's part. Okay, so 28, it's part of, or it's within the range. 29, it's within the range. 34, it's not already part of our range. It's not part of our scope. So with that in hand, we only have how many scores? We have 1, 2, 3. So there, you place 3. Okay, so that is the reason why I have, or that is the reason why the first step is for you to arrange your data from lowest to highest for you to easily identify the frequencies. Okay, so next, uh, how many students have earned a score within the range of 33 to 38? So that's for our frequency. So you go back again to your data. uh, we are computing, or we are counting the frequencies of students from 33 to 38, or students who got a score from 33 to 38. So we have 34, it's within the range. Okay, 35 within, 37 within, the 38 is the max number. So with that in hand, we have how many figures, or how many uh, scores? We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So place 9. Okay. Next, how many scores would fall under the range of 39 to 44? So we have 39, 39, it's within. So 43 is within up to 44. So we have 1, 2, 3, 4, 5, 6, 7, 8. So you place 8. Okay, and then the last 45 to 50. Okay, 45 to 50. So we'll be having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so place 11. Okay, so uh, there might be an instance in which, let's say, after identifying your upper limit, okay, based from your data, let's say there's a person who got 51. Okay, but based on our frequency distribution table, our highest number lang is 50. So if that's the case, okay, you just need to change the highest upper limit, okay, to cover the highest value. So if our highest value is 51, but based on our computation, we only have 50, then you can just change this as 50, or you can just change this figure into 51. Okay, but uh, that's actually a special case. Okay, so there. Next, we will now be computing for our less than cumulative frequency. So again, this is an easy process. So as I've stated a while back, you will be starting always at the bottom. Okay, so for our less than cumulative frequency, the first item will be equal to the first number which is found at the bottom of your frequency column. Okay, so to simply put, you will just copy. So in here we have 1, you just copy, so you place 1. Okay, next, for us to get this figure, or this value, we'll be using again your frequency column, okay, in which this is the pattern. Okay, so you will be using these two figures in which, diba, this is the first less than cumulative frequency that you have identified, in which you have only copied it from frequency. Okay, so you have 1, so you have copied it here, so place 1. Next is for you to add the next frequency. Okay, so 1 plus 3 equals, you place it here, that's 4. Okay, so that's how are you going to compute for the less than cumulative frequency. So next, okay, for us to get the next item, the next number, so you follow the same process. 4 plus 5 equals 9. Okay, so for us to get this one, 9 plus 3 equals 12. So there. Okay, 9 plus 3 equals 12. And the next, 12 plus 9 equals 21, followed by 21 plus 8 equals 29. And then last, 29 plus 11 equals 40. Okay, so how are you going to check whether your answers for cumulative or less than cumulative frequency and your frequency are correct? Okay, so you go back to the number of data, your n. Okay, so saan galing yung n? I guess, okay, don't have it here. So if we will go back to the given, okay, so Mr. Marcelo actually has 40 students. Okay, so if you will go back to the data, you have 40 scores, so meaning the number of data that you have is 40. So for you to check whether frequency is correct, less than cumulative frequency is correct, for frequency you add all of these numbers. If it's equal to our n, which is 40, then it means that your frequency column is correct. Okay, and then for your less than cumulative frequency, you look at the topmost value. If your topmost value, which is 40, is equal to your your number of data, which is 40, then your answers here again are correct. Okay, so that's one way for you to check whether your answers are correct or not in terms of this two columns. And last, for our relative frequency, this is our formula. You have frequency per row divided by n. So our n is 40, which is given, and then multiply by 100. So n actually represents the number of data that you have. Okay, so in this case, it represents the number of Mr. Marcelo's students, which is 40. Okay, so there. So for us to compute for a relative frequency, as stated, we'll be using the equation. So for this cell, again, we will be starting from the bottom. So we have 1, which is the frequency for this row. Okay, 1 divided by n, which is 40 times 100, so that's 2.5. Okay, next, 3, which is the frequency for this row, because this is what we are trying to compute for. 3 divided by n, which is constant, so that's 40 times 100 is 7.5. Okay, for us to get this one, we have frequency, so 5 divided by n, so 40 based from our given, times 100, okay, so that's 12.5. Okay, so there, 5 over 40 times 100. And then we have 3 divided by 40, okay, 3 divided by 40, so times 100, that's 7.5. So the same with this one, okay. And then if we will complete the data, we'll be having the following figures. So how are we going to check whether our relative frequency is, or our relative frequency column is correct or not? So the way for you to check whether it's correct or not is by simply adding all of these percentages. So it should be equal to 100%. Okay? It should be equal to 100%. So if we will add all of this, so if we will add, it's actually equal to 100%. Okay? So that's how you are going to compute for the frequency distribution table. I hope that um, you have followed the steps, and I hope that you have learned something from this discussion.